Now, what we're going to do is we're going to move over to the watch. And we're going to set up the watch so that it can display the same program details we have in our storyboard. To do that, we're going to move over to our interface.storyboard. And you'll see that it looks just like a typical view controller. Now we have a few extra things here, but really this is our home page right here. Right? This is where the app's going to begin. So we have interface controller, and I'm going to expand on that there. So what I'm going to do is I'm going to start off in the home page right there. Put a label. Now you'll notice that we have very limited real estate here to work with. So just a label. So it actually kind of nicely puts stuff on in sort of a stack view for us. So one on top of the other. So for my label, I was going to put, conference app. Maybe center it, and then add some buttons. I don't really have much choice in the sizing of the buttons, so just sort of throw it on. This one's going to be our program or schedule. Maybe we'll add another button just for illustrative purposes, but they'll be non-functional. And we'll say speakers. Yeah, another button, announcements. All right, that'll be our home page. Now, we want to add another screen to this watch app, so we're going to add another interface controllers. Like I said before, interface controllers are like view controllers for the watch. So now, with this new page, what we're going to do is we're going to start with a label. And I'm going to stretch this across. And say program. And now we're going to set up a table here. So I'm going to search for table. Throw a table on. And so here we have table row. Let's look at our document view here. We have interface controller, we have a table, we have a table row controller, and what we're going to do is we're going to start with little groups. We're going to group things together. So designing tables here is a little bit different than what we do in an iPhone. So I'm going to put a little group container in. And this group container is going to house my title and my speaker. Actually, we already have one, so I can go ahead and just start adding labels. So I'm going to put a label there. This will have the word title. And we'll leave it as white. I'm going to stretch it across the screen. I'll leave it left justified. Another label below. So, it should go right below. So as you can see, it's a little bit finicky to put things in. And actually, what you need to notice with the group is that you have to set an alignment. So it says layout horizontal. Let's switch that to vertical. And there we go. It's right below there. Just got to make it visible. There we go. Let's just stretch it out a bit so it's easier to work with. So you have the label there, title there, there. That's better for sizing's sake. And this will be speaker. Color, let's change the color a bit. Go with like a purple. And now I want to put from and to side by side. So to do that, I need to add a group here. That group will go horizontal. So I'm going to put a group right below. Right, and now I can add some labels. And so now this will be from, make this blue, and we'll put another label next to it, to. And maybe we'll change this to be a goldish color or yellow. There we go. And that'll be our little table view. I'm going to stretch this out a bit just for visibility's sake. All right. Now, let's give our table cell an identifier. I'm going to call it prog row controller. And I also need to add a new object here. So similar, actually I have to add two new objects. So I need a new view control or interface controller for this screen, this new screen, and I also need an object for the table cell. So I'm going to right click on special classes, go to new file, iOS Cocoa Touch class, and this will be a an NS object, which is odd because we're accustomed to using UI table view cells, but we're not dealing with a table view, a conventional table view like we do normally. So this will be, we'll call it prog row controller. Type NS object, language is Swift, and we'll hit next, give it a home. All right, so it goes under special classes. Now under interface controllers, we're gonna add a new controller, new file. This time WatchOS and WatchKit class. We'll hit next, and this will be a WK interface controller. I'm going to call it program interface controller, language Swift. Actually, it does give you the option for Objective-C. In case you want to code in Objective-C, you're more than welcome to. We'll hit next and give it a home. Now I'm going to start with the prog row controller and define all of my outlets inside this one. So I'm going to say at IB outlet var LBL title extends WK interface label exclamation mark IB outlet var LBL speaker WK interface label. We'll say IB outlet var LBL from extends WK interface label, and finally IB outlet var LBL2 extends WK interface label. All right, and that's all I'm going to do with this program object. Leave it alone like that. We also have to import WatchKit instead of UIKit here in order to get rid of this error. And there. Now our object is safe. Now going back to my interface controller, my interface storyboard. First thing I do is cast my interface controller using my identity inspector to my program interface controller. And then the next thing, I'm going to take my prog row controller and cast it as a prog row controller. All right, and at this point I can start connecting things up. So going over to my connections inspector, I should see LBL from. I'll see speaker, title, and to. So things are connected up there, and schedule we're going to connect it up to this page. And we'll do modal. And so now we have a segue from the schedule button to our new page. And now to run it, we now have to run two apps. So we want to get the watch simulator to run, we have to change our target to the WatchKit app. All right. And then furthermore, we can change our simulator to be iPhone 7, Apple Watch Series 2. Right, 38mm is good enough for this application, and we'll hit run. So our watch comes up. Now what's odd is that our simulator does not come up anymore. Well, it comes up, sorry, our app for our simulator doesn't come up. I have to manually run this. Right, and we'll find this to be a bit of a pain when we're trying to do connectivity. So there we go, we got conference app, schedule, speakers, announcements. We have an empty table. We have a cancel button to go back. So at least we're good. We're able to launch this application, get our UI to display. All right, now the next step is to get connectivity going, and we're going to start off. Now we have two devices to work with. We have the watch and we have the phone to work with. So we're going to start off on the watch side of things, and we're going to finish off on the phone side of things. So starting off with Program Interface Controller, we have here Program Interface Controller, WK Interface Controller. All right. Now what we're going to do is we're going to define a couple of variables, and we're going to bring in a delegate. So first thing we'll do is we'll do an IB outlet. Say var prog table extends WK interface table with exclamation mark. And then the next thing we're going to do is we're going to bring in an array. So we'll say var programs extends, so same array as the iPhone side of things. We'll say program object, and we'll make it empty. And let's look through our errors here. Now, it's complaining about program object. It does not know what program object is, but you see, we see it right here. We're like, wait a sec, program object's up here. Why can't I see it? So now this brings in an interesting dilemma, because we have an object that exists in another folder, another group, but we could see it, we just can't touch it. It's like be on the other side of a glass door. So we need to make it available on this half of the app, or this half of the project, so that our watch side of things can take advantage of it as well. To do that, we have to actually go over to our project settings. So up here at the top, and we're going to go to build phases. And you'll see here I have a little document view on the side here. I'm going to extend that a little bit because we never touched this area in our lessons, but we're going to touch it today. Now, kind of challenging to do, but anyway, we have our iOS app side of things. The build phases here, let's look at compile sources. All of the files, objects that we care about to compile are here, including program object. But if I go to the watch app side of things, so the little bottom one here, and I extend it, my program object is not here. So to do that, I'm going to hit the plus sign, and I'm going to look for program object right there, hit add. So now it's going to say, hey, I want you to bring in program object into this side of the application as well, or this side of the project as well. Now if I jump back to program interface controller, it's gone away. So now program object is allowed to be in this project as well, in this half of the project as well. So now I can focus on connecting or doing watch connectivity. So watch connectivity is a library that was introduced in Swift 3 and as of Watch Series 2 to allow data to be transferred to and from the watch. Now before then, you had to actually bring in an external library But because that external library got so popular, everyone was doing it, Apple realized, well, we're going to add this into, we'll add this into our kit as well. So might as well. So they created Watch Connectivity. So I'm going to import Watch Connectivity. And so now I can bring in a new delegate. That new delegate will be WC Session Delegate. Now it's going to complain, saying, hey, you've got a bunch of missing stuff, which we now have to fix. So we're going to, and it doesn't autocomplete, unfortunately. I wish it would. That would actually save us a lot of headache, but that's okay. So what we're going to do now is we're going to implement some special methods that will allow us to do transferring of data between watch and phone. So first thing, I'm going to start with a method called activation did complete with. Hit enter, and it has activation state, it has everything I need. I'm going to leave it empty for now. And the next method I'm going to bring in is did receive message. Did receive message. There's a few options there, so I have to be careful what I want. I want the one with the reply handler. And we'll use the any. There. We're going to come back and fill in this method in a moment. This one will be used to receive data from our phone and what to do with it. We'll come back to it. For now, what we'll do is we'll just jump over to our awake method. Now, you'll notice that the interface controller, where's the view did load? And it's not here. We're going to deal with awake instead. And we have also will activate, which we can use as well. And we're going to use this to populate our table. So will activate is kind of like our view did load. Awake, same functionality as the awake from a view controller and a phone. But we'll start off with awake. What we want to do is we want to test to see if we can actually do any watch connectivity. So we're going to say if WC session dot is supported. So this kind of tells us, hey, what version of Watch OS are we using here? Then we'll say let session equal WC session dot default session dot delegate equals self, and session new line, sorry, session dot activate. So we're activating a connection. That's the first thing we're going to do. Now, when the session is activated, what we're going to do is we're going to fill in the blank for our did receive message method to basically unserialize or decode any data we have. So first thing we're going to do is we're going to say var reply values equals dictionary, where it'll be a string and any object. All right, then we'll say let loaded data equal message. Where did message come from? Well, let's look at our arguments here. We have message. All right, and we'll pass in prog data. And then we'll say let loaded person equal NSKeyedArchiver. Sorry, Unarchiver. Be careful of this. Not archiver, but you want Unarchiver because we're on the watch side. We're going to decode the message sent. We're going to use Archiver on the phone side of things. So we're going to say NSKeyedUnarchiver dot unarchive object, passing in loaded data as data. So data, as you know, is just a generic set of bytes. We'll say as an array of program objects. All right. Now I already have an array of program objects, so I'm going to say programs equals loaded person. exclamation mark. And I'm going to send a message back saying reply values of status. It probably the phone side of things is looking for a response saying, hey, did we get it? We'll just say program received, just so it doesn't try resending it as any object. We'll say reply handler reply values to go ahead, send it back, send that message back. So this method, it's going to handle being able to send, it's going to handle decoding what the data is that's come in, and it's going to send back a message saying program received. So this handles our decoding of data. All right. So now let's get into populating our table. Now, as you can see, the table acts very different from what we're accustomed to seeing in a table view. There's no conventional table methods that we have been dealing with. Instead, what we're going to do is go to will activate, and we're going to start trying to populate our table. So first thing, we'll check to see if we can connect to our phone. So we'll say if wc session dot default dot is reachable. If it is, keep going. Then we'll say let message equal get prog data. We're going to do a tuple inside of there, and we're going to send a message to say get prog data. So now we're going to tell the phone, hey, I want some data, send it to me. So that's what this whole message is. So we're going to initiate the messaging between the phone and device. So the phone's going to say, hey, send me the program data. Now we'll say wc session dot default dot send message for message, comma, with a reply handler. All right. Now I'm going to add extra space because the reply handler is now going to handle getting the data. And so we'll open up a curly. I'm going to close my curly down here. There, they'll be lined up. My arguments will be result. Just one argument. Void return type. I've got the arrow there. In. And now I can write my code to handle populating the table. So now, I'm going to say if result of prog data, sorry, lowercase prog, p, because I'm going to pass it in that way, does not equal nil. Open up a new set of curlies. So making sure we have data. We're going to say let loaded data equal result of prog data. So what we're going to do on the phone side is we're going to send our data back. We're going to call it prog data. So we're looking for prog data here. Now we're going to unarchive everything. We're going to deserialize, unarchive, and load it into our table. So we're going to say NSKeyedUnarchiver dot set class. Now we're going to say program object dot self for class name program object. Then we're going to deserialize. So we'll say let loaded person. Now for readability's sake, I'm going to kill off this side here. There, let loaded person equal NSKeyedUnarchiver dot unarchive object with data, which will just be loaded data, because right now raw set of bytes as data as an array of program objects. Now self.programs can be converted into a loaded person, and we'll say self.progTable.set number. Now we can get into the table itself. So now we're going to set the number of rows. We'll say self.programs.count. So you see we're doing some very different work here to configuring the table. Up until here, I'll come back and finish that line in a sec, but up until here, this was all about watch connectivity, receiving data, deserializing it. Now, from here on in, we're going to configure our table. At this point, we have our data. We're going to configure our table to display our information. So it says here row type. We already have something called prog row controller, and this is the same label from our interface storyboard, interface.storyboard that we set by hand. Now we can use a for loop to loop through cell by cell and display. So we're going to say for index, comma prog in self.programs dot, we're going to enumerate it. So enumerated. We have a closing curly there, and we'll say let row equal self.progTable.rowController at index as prog row controller. Now we can populate our items for our particular row. So we'll say row.lbltitle.setText for prog.title. So this looks like our self-row index path on the iPhone side of things. Row.lblSpeaker.setText for prog.speaker. Row.lblFrom.setText for prog.from. Finally, row.lbl2.setText for prog.to. And we'll leave details out of this. Now, we also have an error handler to implement here as well. So we have our for loop here, which matches up with our for loop. We have this other curly here, which matches up with our if. And we have another curly here, which matches up with our reply handler curly. Now from here, we're actually going to add a comma and say error handler, which will be another block code. So we'll pass an error, and we'll just say void in, and just do a little print for error with a closing curly. And at this point, we have our handling of receiving our data from the from the phone. All right, now that we have the serialization for the watch done, so we're able to receive our data from the phone, and we're able to display it on our Apple Watch, now this next step is to actually write the code to send the data from the phone to the watch. So we've done the second half of stuff. We're a watch, we're receiving data. Now we're going to send data. And to do that, we're going to switch over to program viewcontroller.swift. And you'll see that when we last were working on this file, we were working on the table code just to get our table to display our data. We still have our array of data, and now what we want to do is initialize a connection with the watch on this end so that we can transfer our data. So we're going to start inside viewDidLoad, but even before then, we're going to need to bring in Watch Connectivity into this view controller as well. So I'm going to start at the top where we imported UIKit, and right below it, we're going to import Watch Connectivity. So now we have the ability to send and receive data to and from the watch. So we have that, and also we need to bring in one more delegate, which is going to cause a bunch of errors. So after UI table view delegate, we're going to add another interface. So comma, we're going to say WC session delegate. So this will introduce some methods. It's going to cause some errors. We're going to fix those in a moment. And so, but we're going to start off with just trying to get the connectivity working. So what we want to do inside viewDidLoad is test for a connection with the watch to see if we're able to do it. But even before then, what we're going to do is we're going to test to see if it's supported. Like make sure we're not dealing with like a Watch 1 or an older iOS version. So we'll start off in viewDidLoad. We have init fake details. We're going to do this last. So just above it, after super viewDidLoad, we're going to say if WC session dot is supported. All right, if that's true, all right, then if that's true, then we're going to get into our session. We're going to try some. We're going to establish a connection essentially. So we'll say let session equal WC session dot default. All right, we'll set the delegate to itself. So session dot delegate equals self, and we're going to activate a connection. So we'll say session dot activate. So initiate a connection. Now we'll test to see the status, at least for ourselves, but maybe for an alert box if in future expansion. But at least for ourselves in the console, we'll test to see. We'll provide a response at least. So we'll say if session dot is paired does not equal true, then we'll say print Apple Watch is not paired. Right? So at least we know there's no connection going on. Then we'll say if session.isWatch app installed. Now we want to check to see if the app was installed or not. So we'll check to see if it wasn't installed. So it's not equal true. Then we'll print out a message. So print WatchKit app is not installed. All right. And so we'll test to see for those two things. Now for the else on the if on the outside, we're going to say else. We'll say watch connectivity not supported. So print watch connectivity is not supported on this device. All right, just to cover our bases. Now we still have an angry view controller, so we're going to fix that as well. But right now, this code, its purpose is to support connectivity, initiate a connection, and get the watch to pair with the iPhone app. All right, now the next step is let's implement a method to get the message to send to the watch. So our messaging method. To do that, we need to actually bring in another variable. And that's going to test the timing between messages. Like if it fails, at least it'll resend. So we're going to add a new var at the top. We're going to say var last message. We're going to use CF absolute time, right? So it's useful for a time between, well, as you can see there, as a reference date of 1st January 2001. So since absolute time. Start equal to 0. All right. Now we're going to introduce a new method. We'll put it just below fake details. there. And we'll say func send watch message. And we'll pass in our MSG data. Now what we want to do is we want to check to see our current time. So we'll say let current time equal CF absolute time get current. So get the current time. We'll check to see if less than half a second has passed. Then we'll return. We won't come back and do anything yet. So we'll say if last message plus half a second, so 0.5, is greater than current time, return. Just so we're not resending a message too soon. That's the purpose of it. Now, we'll check to see if we are connected to the watch. So it could be that maybe we left our phone at another part of the building we're in, maybe in our house. We go away to maybe the kitchen, for example, and our phone and our watch are out of range of each other, for example, right? So we want to test to see if it's reachable first. So we're going to say if WC session dot default dot is reachable. If it is, we'll go ahead and we'll send our message. So we'll say let message equal. We're going to call it prog data. Now remember we had a prog data label in our watch app. So we want to make sure this tag matches up with the watch. And we'll pass in MSG data. Right? So this prog data on the watch side, they're going to look for this label called prog data. So we want to make sure it's there and it's typed in exactly the same way. So now that we've typed it correctly, we're going to send our message. So we'll say WC session dot default dot send message. And we'll send a message with the reply handler, but we'll set the reply handler to nil. So our message will be message. Our reply handler will be nil. And I won't bother with an error handler. So I'm going to take this one out. So we'll use that version of the method call. And we'll update our last message time counter. So we have a timestamp of when this was done. So we'll say last message equals CF absolute time get current. So now we have a timestamp. So now this, if we try resending the message, it'll check to see if it's been like, less than half a second since it was sent. But other than that, we have our messaging method to go ahead and send our data. Now let's return back to init fake details, where we had created this array of items. At this point with init fake details, let's go ahead and send this data off to our watch. So we're going to say let program data. So this is at the end of init fake details. We're adding this code in right after our inserting into the array. We'll say let program data equal NSKeyedArchiver. See, now we're going to archive our data into a serialized set of bytes for sending to the watch. So NSKeyedArchiver, as opposed to NSKeyedUnarchiver, which we've been using all along, we use archiver to archive it. Dot archived data, right? With root object being programs, our array. And we'll go ahead and send watch message, the method below. We'll just send watch message, passing in program data. All right, now that we're able to send our message data, let's get rid of that error message by satisfying the requirements of having WC session delegate. So we need to add in some methods. We'll keep them empty for our application here today, just because of timing, and you can expand on them in the future. But let's look at these methods that we need. Unfortunately, Xcode doesn't autocomplete, so we can't just auto stub these methods. So we're going to bring in a method called activation did complete. right? We'll leave that empty. So this method, its purpose is to, I guess, launch some extra coding if once we've completed, maybe have a print message, alert box, or something. Now, we want to have a handler method for supposing our session became inactive. So we'll say session did become inactive. Keep it empty. We don't have time to add some extra stuff here. Finally, we need something just in case if we lose connection. So session did deactivate. And there. So those are the three methods we need, and our error goes away, so our program view controller is happy now. And so we have these support methods. Now, there's one last thing we need to do, and that is to test to see if we received any messages back. So what's going to happen is, so we actually did on the watch side was we received our messages, we unarchived it, we converted to an array on the watch side, and then we sent a message back inside program interface controller, right? And so if I jump back to that, we did send a message back, right? And so we want to make sure that we received that message to make sure that we had completed the transfer of data. So what we're going to do is actually bring in another method below, and we'll say did receive message. With a reply handler. So actually this one. All right. We're going to actually populate this method. All right. So first thing we're going to do is we're going to deserialize any value that came in. So we'll say var reply values equals dictionary. And this dictionary will consist of a string and any object. Now we'll check to see that we actually got back the get prog data message. So if we look at our watch, we actually had sent a message earlier saying get prog data, so go ahead and send our data. So we're checking for this label that's going to come up. So I'm going to say if message of get prog data does not equal nil, meaning we received a message and that message was get prog data, which is essentially our array of stuff. So we're testing to see if we can get our stuff first. So now we can go ahead and send our data at this point. So this is the point where we're actually going to send the data. So we're going to do an NSKeyedArchiver dot set class name to program object. So they're going to watch for program object in the watch connectivity side of things for program object dot self. All right. Now we're going to archive our data. So we'll say let program data equal NSKeyedArchiver dot archive data with root object being programs, the array that we have of our stuff. Now we're going to go ahead and send our stuff. So we'll say reply values of prog data is equal to program data as any object, question mark. And then reply handler for reply values. All right, so now we're able to send off our data. So you notice that first our watch is going to say get prog data. It's going to send it to us. At this point on the phone, we're going to receive this message called get prog data. Now we're going to take our array of items, we're going to serialize it, and we're going to send it off with a label called prog data. So now the watch will look for a label called prog data, and it will deserialize that data as an array of program items, and it will display it in its table view. All right, now there's one last thing we have to do before we can run this, and we kind of skipped over this step by accident, but we have to just jump back to our interface.storyboard, and we should have done this connection before. Now, we created an IB outlet for our table over here, but we haven't connected that IB outlet. So I'm going to expand the document view, which is already expanded. If you haven't already expanded it, so that's the button to expand it. Under Program Interface Controller scene, I'm going to expand that. See table, this is just a generic table. And if you run this, it's going to cause an app crash right now, right? So I'm just going to expand this, actually highlight Program Interface Controller, and go over to our Connections Inspector. We have our outlet, which is prog table. I'm going to connect it up to this table object right here. Now, because I'm always nervous about connecting to the wrong thing, I'm just going to connect it directly to the table in the document view. So now it's become prog table. Now we can finally run this app. So now I'm going to hit play. And it's going to launch the simulator. So our watch simulator is here. Now for some reason it doesn't automatically launch the iPhone app. All right. So my watch app has launched nicely. I'm going to actually swipe over and find my iPhone app, Watch Conference. Double click or single click on it. It's launched it. I'm going to run program here. Now the way we have it set up, we're going to run program and look at our little program view there and look at schedule. Click on schedule. Now this gets a bit finicky. So there's a lot of finickiness between watch and the phone, and we'll find that in our next application with complications we're going to have the same issue as well. But there's a bit of finickiness. Now it did say WC session has not been activated, but what happened was behind the scenes it probably has activated by now. So if I hit cancel, I hit schedule again, it says now it's saying it's already in progress, and here we go. We have our complete data received from the table view. And now we're able to watch our conference or check out our conference schedule with ease from our watch instead of having to open up our phone and look up stuff right away. So essentially this is the completion of the app. What we learned about here was how to first create a watch app, how to create a project that has an iPhone app and a watch app, and we'll find that we need to actually create that type of app where it actually has both iPhone and watch, and it actually grows our project immensely with a lot of extra files, a lot of things to think about. And then we had to figure out how to share objects between the two projects, or the two sides of the coin. So we created that program object that was only visible on the iPhone but wasn't visible on the watch. So we had to learn how to make it visible on the watch. We learned all about Watch Connectivity, so WC session delegate, and learning how to transfer data to and from the watch and the phone. And we learned all about archiving and unarchiving data and sending data between. In our next app, we're gonna step away from the watch connectivity and focus purely on the watch here and learn about something called a complication. So in complications, we have the ability to modify the watch face to have our own custom little widget on the watch face, and that's what we're going to focus on for the next application.